All right, in this video, we're going to be talking about section 5.2, which is going to bring us our third rule for exponents, and that'll be the multiplication rule. And so we're going to start with a couple warm-up questions, which I'd love for you to pause the video and cruise through very quickly. All right, so warm-up number one is just asking us to get comfortable with this idea of what is an exponent. And an exponent is just a more efficient way of writing a repeated multiplication. So we have 1, 2, 3, 4, 5, 6, looks like 8 t's being multiplied together. And we know that as an exponent, we can write that more efficiently. So t to the 8th would be the answer here. 1/3 times 1/3 times 1/3. Let's be careful here, because if I write 1/3 cubed, it leaves up to it leaves the interpretation of this up to the reader. And if you showed me this question, I would assume you kind of meant 1/3 cubed, but what you really have written is 1 cubed divided by 3. And 1 cubed divided by 3 is just 1/3. So this is not really what we mean. What we really mean is 1/3 cubed. And now the message is very clear what's happening. All right, 1, 2, 3, 5 fives, so 5 to the 5th power. In this case, maybe a little bit weird, but we have 3 things being multiplied together 3 times. So we just have x plus 3, and we're going to do that 3 times. All right, next up, warm-up number 2, trying to get you, again, comfortable with this idea of what's included and what's not included when you're dealing with negatives. So in this case, the negative is not part of the 5. It is separate. This problem simply says you have a negative, technically maybe even like a -1, times a 5, 5, 5, and 5. So there's 4 normal 5s and then a negative. So the 4 normal 5s make, grab your calculator if you need to, but that's 625. And you still have a negative out front, so it's negative 625. Jump ahead to part C to contrast it with that one. Now you see the negative is in parentheses with the 5. And so this problem is not saying what the last one did. It's saying essentially this. The negative is happening 4 times, as is the 5. So 4 5s make 625, and then 4 negatives make a positive. And so the answer would be positive 625. So please make sure you pay attention to the difference in those two statements. This one, the negative is included, and anything raised to the 0 power is simply 1. And then on part D, the negative is included, the negative 4th power. So technically that would be, we still have negative 5 to the 4th in the bottom, and we just did negative 5 to the 4th. So we know this is 1 over 625. All right, so then let's get into our first example of today. And today's rule is very straightforward. I think you won't have any trouble with this. What does 8 to the 4th times 8 to the 3rd mean? And if we just look at it at a very basic level, it means we have 1, 2, 3, 4 8s multiplied together. And then it says times. And then we have 3 8s multiplied together. Well, what we need to understand is there's no extra special value on that multiplication than any of the other multiplications in this problem. So this is really just 1, 2, 3, 4, 5, 6, 7. This is 7 8s, which we know is 8 to the 7th. And of course, what does that mean? We had 4 of them here and we had 3 of them there, and 4 plus 3 is 7. Here we have 2 8s times 5 8s. And once again, if we just add these up, again, no special value for that multiplication. It's just one of many. And so really we just have 7 8s again. This time we got there by adding 2 and 5. And of course, on this one, we're going to have 1 8 and then 6 more 8s, getting too lazy to write them. And so altogether, we're going to see that once again, we have 7 8s. So 8 to the 7 power. Now, how do we arrive at all these? Well, like we said, this is 8 to the 4 plus 3 power. 4 plus 3 is just the exponent of the 2 that we're multiplying, and we add them together. This is simply 8 to the 2 plus 5 power. This is 8 to the 1 plus 6 power. 2 8s and then 5 more 8s makes 7. 1 8 and 6 8s make 7. All right, so very straightforward, and that brings us to our rule. If you are multiplying numbers that have the same base, so the key is that it has to both be the same number here, then all we do is add the exponents together. This rule comes from very, very base logic, as we just saw. So it's one that, like, yes, memorize the rule, but more than that, understand where it comes from, because then you don't even need the rule. You just do it. All right, we're going to breeze through some examples very quickly, so you can watch it again if I'm going too fast. 11 cubed times 11 to the fourth. We don't need to write all the 11s. What we know is this just means we have 3 plus 4. We have 7 of these 11s, which we're not going to bother to simplify because it's way too big. X to the second times x to the fourth, we know is just going to be, there's 2 of them, and then you have 4 more, and then you have 6. When I see a problem like this, by the way, I'm basically seeing all the x's multiplied out in my head, and I'm just knowing that there's 2 of them and 4 of them, and there's 6. So my brain kind of sees it as a visual question more than a just add the 2 together. It is the same thing. I'm just saying, that's why I don't really have this memorized. I just understand the logic behind it. All right, this one, we're going to look at 2 ways. Let's follow the rule. It says, same base, multiplying, add the exponents. Negative 2 plus 2 is 0. This is 5 to the 0, which we know is just 1. So let's look at this another way. Let's look at this as our first 2 rules. We know that 5 to the negative 2 means 1 over 5 squared times 5 squared. So this becomes 1 over 25 times 25, or just 25 over 25, which we know is 1. Okay, so however you look at it, the answer becomes 1. Certainly, doing it with today's rule makes it very quick. We have multiple 2's here, but they are all still 2's, so this is technically just 5 plus 2 minus 1. So that's 7 minus 1 is 6. This is simply 2 to the 6th power. 2 to the 6th power is one that, it is a lot of 2's being multiplied together, but the number doesn't get very big. It would be great if you know all your 2's. 2, 4, 8, 16, 32, 64, right? So this one is going to be simply 64. But I would take that. Let's keep going. X, X, and X, they're all X's. This one is an X to the first power, so we're just going to add them up. We get 4, 5, 6, X to the 7th. All right, and then we look at F. This one's a little bit different, and you're going to try to do weird stuff with it, right? You're going to start making up new rules for math, or confusing the old rules. We're not adding 2 plus 3 here. These are not exponents. Those are numbers. This is all just multiplication. There is no special connection between the 2 and the end of the fifth. It is just a multiplication, just like this multiplication right here. So mentally, I don't ever really write this when I'm showing my work, but here's what I'm seeing in my head. I'm seeing this as a 2 times an n to the fifth times a 3 times an n to the negative 2. It's all just multiplication. Again, no special relationship with the 2 and the n. They're just separate numbers being multiplied. And so I can multiply in any order. So once again, I wouldn't necessarily show this, but in my head, I know I can do the 2 times the 3 first, and then I also have an n to the fifth and the n to the negative 2. So once again, I don't write any of that. I just look at this problem, and I'm like, okay, I can do 2 times 3 and get 6. And I've got n to the fifth and n to the negative 2, and I add the exponents, and I get 5 minus 2, which is 3. This is 6 times n to the third. The 6 has nothing to do with the third power on the n. They're separate numbers. So again here, I just know I've got a 6 times a 3 times a 2, which I can multiply in any order. Doing 3 times 2 and getting 6, then multiplying by 6 seems like the easiest route to me. So that's just 36. And then I've got all my y's. I've got 2, 3 more, and another one, which makes, was that 6? Here, please notice, this is a D, not a C. I cannot cram all those together. So I'm going to take my C's and combine them and make C to the 6th, and then I've got D to the negative 3rd. Since we have a negative exponent and it's considered unsimplified to leave that as a negative exponent, we're going to do what a negative exponent means, and we're going to move it to the bottom. So this just becomes c to the 6th over d cubed. None of these rules are hard on their own, but there's a lot of rules we're going to learn, and that's where it can get confusing. So it's really important you learn each rule as we go. All right, multiplying again in any order. I'm going to do the numbers together. 5 times 2 is 10 times 3. That's just 30. Then please be aware, this is just a y to the 4th all by himself, but I have 9 x's. So I have x to the 9th, and then I'll just tack on the y to the 4th. We always do it alphabetically. All right, last problem. Looks like I have 2 sets of y's, only 1 set of x. 2 times 2 is 4. 4 times 7 is 28. X's, I've got only 1 set. I want to do it alphabetically, so those come first. And then I've got my y cubed and my y to the 4th, which makes y to the 4 plus 3, which is 7. All right. So hopefully that all makes sense. Let me know if you have any questions.